Well, good afternoon, folks, and thank you for joining us for the California Fire Science Seminar Series. My name is Caden Chamberlain, and I'm a member of the student committee who assisted with planning this webinar series, and I'll be your host for today. I'm a PhD student at the University of Washington, and my research focuses on using remote sensing to evaluate how disturbances and management activities impact forest structural patterns and resilience, primarily focused on the Sierra Nevada. And I work closely with today's guests, who I will introduce shortly. So I'm excited for the opportunity to host today's webinar. The California Fire Science Seminar Series is organized and supported by the Berkeley Fire Research Group in the College of Engineering at UC Berkeley, UC Merced, and also the California Fire Science Consortium. And before I introduce today's speakers, I'll go over a few housekeeping items. So this webinar is being recorded and will be posted on the California Fire Science Consortium website and YouTube channel. All registered participants will be emailed a link to this recording once it's available, generally within about a week. And this email will also include a brief evaluation survey, which we hope folks can fill out to help us improve future webinars. All right, so now to introduce our esteemed guest speakers for today, Malcolm North and Mark Meyer. So Malcolm North is a research forest ecologist with the U.S. Forest Service Pacific Southwest Research Station and an affiliate professor of forest ecology in the Department of Plant Sciences at UC Davis. Malcolm received his PhD from the University of Washington, and his research focuses on forest restoration and ecosystem response, wildlife, wildfire, and forest carbon dynamics, with an emphasis on Sierra Nevada mixed conifer forests. Malcolm has over 25 years of experience in this field and has published over 200 articles. And I can personally attest that Malcolm is truly an expert in Sierra Nevada forest ecology. And then next we have Mark Meyer, who is the Southern Sierra Province ecologist with the U.S. Forest Service Pacific Southwest Regional Ecology Program and serves the Inyo, Sierra, and Sequoia National Forests. Mark has a PhD from UC Davis and has many years of experience studying the effects of fire and other restoration treatments on California's ecosystems. He's published several peer-reviewed articles, including the recent GTR 270, which provides a post-fire restoration framework for national forests in California. And also, having worked with Mark for a few years now, Mark is certainly an expert on forest and fire ecology and is especially skilled at translating ecological concepts into actionable management strategies. So today, Malcolm and Mark will be delving into the topic of post-fire reforestation strategies to promote resilient fire-adapted forests in California. This is a timely topic in California, and we are lucky to hear from two of the leading experts on this topic in today's talk. And following Malcolm and Mark's presentation, there will be a Q&A section. So please feel free to add any questions that you have to the Q&A chat throughout the presentation. And now please join me in welcoming Malcolm North and Mark Meyer.
All right, thank you very much, Caden. It's a pleasure to be here today with everyone virtually. And as Caden mentioned, Mark and I are going to tag team this like some kind of wrestling team. And I will be going first. I just wanted to start with a little bit of context. Obviously, those familiar with California know that we've got a slight wildfire problem in the state, and that there's been a lot of changes in terms of both fire activity and what post-fire conditions look like. And so we've been working on this subject for a while and decided, well, or come to the conclusion that it's time to think, or at least consider other reforestation techniques than we're currently using. So with that as a context, let me begin here. Let's see here. Oops, that's not, oh, wait a second here. Okay, there we go. So first, what I want to do is just start with a little bit of context. As I mentioned, The wildfire problem in California has gotten pretty severe, particularly over the last couple of years. The size of high severity patches has dramatically increased. And because of that increase in size, seed trees to regenerate or reforest areas that have burned severely are often a long ways from the center of these areas that have experienced high severity. And in the lower right, you'll see a graph from a really nice paper by Gina Kova that really looked at the changes in severity patterns going on within that. And if you look at the red line, the high severity, you'll see that particularly in very large fires is where you get a significant portion of the high severity acreage that's occurring in California. Obviously, the byproduct of that is you've got a tremendous increase in the need for reforestation and replanting these areas. And there's a paper currently under review with a whole host of us that have tried to look at what the shortfall is, or what Solomon Dubrowski, who's the lead author, calls minding the gap. And he means the gap between the need for reforestation and what is actually being produced. So you see in the left-hand graph here that the red dots are the estimated annual reforestation need. But what I think is very valuable about this graph is that often what is needed and what is actually planted, there's a significant difference between the two. And in this paper, there's been an effort to look at the kind of cumulative backlog, which is the gray bars. And you can see how dramatically they're increasing in terms of the shortfall between the amount of seedlings that are needed and what is actually being planted out in these fires. And the right-hand graph takes those projections and then runs a suite of 30 climate change models in the future and looks at the projected trends in seedling reforestation needs through the end of the century. And you can see with where the blue line trajectory is going in that graph that not only do we have a current significant backlog, but it's expected to get much, much worse as most of the climate models predict a really significant increase in the size and severity of wildfire. So within that context, let's take a look at current reforestation practices after wildfire. And this slide tries to sum that up in a short and sweet summary. But I think that what we mostly see after high severity fire is that largely most of the seedlings planted are pine, and they tend to be planted in a regular gridded pattern. There are certain real advantages to that type of approach. It bypasses the uncertain seed stage by actually getting stock put in the ground that's usually 2 or 3 years old. So survival rates of planted stock tends to vary a lot between locations, but often the figures I've been able to find are that somewhere between 60 and 80% of planted stock usually survives to year 5. The focus on spacing the trees widely apart is to increase or favor rapid growth because there's very little competition between the seedlings for the first few years. But they're still spaced at a distance in which after a certain number of years, often about 8 to 10 years, the crowns are large enough that they start to interlock and shade out competing vegetation, which often in the case, particularly in Mediterranean systems like California, are a suite of shrubs which can be aggressive competitors. But we'll get into that a little bit more, particularly in Mark's half of the talk. So with that kind of approach, I would suggest there's several problems with at least the way conditions are changing in the modern era, particularly with the severity of fires and also the stress that's coming with climate change, particularly in terms of drought conditions. So the first thing I point out is that the high density rates at which these seedlings are being planted. The gray box shows what Region 5 is recommending in terms of acceptable stocking levels for different different forest types. And if you look at those numbers in the third column, the recommended TPA, you can compare that to the historic densities, which have been developed from quite a number of papers reconstructing what forest conditions looked like when the Sierras had an active fire regime. And you'll notice that between the ponderosa pine, the red fir, and the mixed conifer, you're generally looking at about 50 to 65 trees per acre, and the levels being planted are somewhere on the order of about 150 to 300 trees per acre. So to circle back to that earlier comment I made, if you're holding on to or at least retaining 60 to 80% of those trees that are being planted, you've got a significant amount more of trees in the ground than you would have in a mature forest that had an active fire regime in it. And that kind of gets to the second point is that most of these techniques are or hinge on having what I'll call course correction following up in the treatments, which is that you've got these higher densities. And so to be able to reduce those in time, you often need to PCT or pre-commercially thin the stand, which gives you the ability to not only reduce the density, but also make some inroads into changing the composition and the spatial pattern of the stand. You also usually need to get in there with some kind of a reduction in the competing vegetation once you thin the stand out. So either manual grubbing of the competing shrubs or spot applications of some kind of herbicide. But the bottom right-hand graph shows that the general trend has been a pretty significant reduction in the amount of money and, well, and particularly directly in this graph on the amount of acres that have these follow-up treatments, so that the high densities that are planted do not necessarily get treated in the future to reduce the density, correct the species composition or the spatial pattern. The other thing that we know pretty well from a lot of recent work is that regular spacing and high densities tend to burn at very much of a high severity when fire encounters them, and that the pattern which was produced in frequent fire forests has often been termed ICO, or individual trees, clumps of trees and openings, which you can see in the top right in a stand from Yosemite that's had a pretty active fire regime since about the 1960s. And there's several papers recently that have looked at the mechanics of what's driving that. And in short, a lot of what reduces the fire intensity in this kind of spatial pattern is that the openings have much less or reduced surface and ladder fuels, and that the wind patterns that are produced within an ICO stand tend to reduce the transfer of the radiant and convective heat, which is what drives the fire into the overstory crowns of the trees. So there's a advantage to the particular structure, spatial structure, that is produced by these active fire forests. So I was interested in what kind of regeneration patterns happen in these forests, particularly looking at old growth forests with restored fire regimes. And I had a student, Hannah Fertel, who did this really nice study looking at about I think about 150 plots in about 30 different stands with different fire histories in them. And the thing that comes out immediately when you start sampling regeneration and the young seedling and sapling stage in these stands is that only 25% of the trees are actually in individual status. Almost all of the trees within the stand, or 75% of them anyway, are growing in clumps of various sizes. And you can see the breakdown here between the different clump sizes, and then below it, how that pattern changes with species, where you can see that the more shade intolerant, fire tolerant type of species like the black oak, the kukui, and the sugar pine, and the Jeffrey pine tend to have more individual and smaller clusters, or tend to be more in the individual trees of the smaller clusters. As you get to the shade tolerance, like the incense cedar and the white fir, and they tend to have larger, or what we're calling large clusters or extreme clusters. One of the reasons why trees have not been planted in clusters is there's a pretty strong belief that trees that are bunched that close together are going to have a reduction in growth rates because they'll be competing with each other. But in the all the seedlings which Hannah sampled in this study, which I think amounted to something on the order of 8 to 10,000 seedlings within this 1 to 30-year-old period, all of the seedlings growing in clumps were growing faster and taller than those growing as individuals. So there's actually a benefit to growing in clumps at this stage. Someone might come back and say, well, at this early stage, competition hasn't set in yet, so that the trees are not experiencing that. But I would suggest that particularly in a stressful conditions that we're having with the future, with current climate change and future projections of more frequent fire and climate stress, that being able to establish, survive, and grow rapidly in the young stages is actually a pretty significant benefit for where conditions are going. The other thing that seems to be going on, which we found interesting, is that the seedlings growing in these high-density clumps seem to get through these frequent fires that are coming into these active fire stands. Most of these are in Yosemite and Sequoia Kings Canyon. And the fires tend to kill the outer rind of the clump, but most of the seedlings survive. And so the clump gets kind of thinned down with each fire, but does not get totally consumed, which was a bit surprising, but seems to be a benefit to actually growing in clumps within these stand conditions. So how could this pattern of ICO, or individual trees, clumps of trees and openings, be fostered? And I think what, to my mind, is one of the most obvious places to start is that certainly we would want to start with planting lower densities than we're currently planting. Something on the order of 70 to 120 trees per acre, of course, depending on what type of forest type and conditions you're in. But starting with a lower density because you're producing less fuel and less problems as fire comes into these stands. The other thing that seems pretty obvious is rather than planting things on a regular grid, let's make some use of our ability to look at and read the landscape and put species into locations that are either more sheltered or wetter or have better growing conditions, and adjust the species composition that we're planting to reflect those differences between, say, in this diagram on the right-hand side, the steeper, drier slopes towards the back of the diagram where you'd have more pine and black oak versus maybe having more fir and incense cedar down in areas where there's concavities or wetter conditions, so that at least you're planting in a manner that's sensitive to where the resources are and should be increasing the survivability and growth rates of the seedlings that are planted. One of the things that both Mark and I have heard frequently is this, it's not a bad idea, but it's almost impossible to implement. And the implication is that you're asking something of planting crews that just can't be achieved because it'll be extremely complicated. And I would say that one of the first things I think both of us would acknowledge is any two planters using this kind of clustering scheme and microsite planting is going to read the terrain slightly differently. And because of that, there's no single one right way of planting these things. But the flexible locations allow you to put seedlings in favorable microsites. And that alone is probably worth a tremendous amount, or a little bit, I would say, amount of uncertainty as to where exactly the seedlings end up. Because you're at least putting them in locations where they're more likely to survive both fire and drought stress in the future. So in this diagram, we've presented an idea in which you would take and space clusters of seedlings about 20 feet apart, looking for particular locations that are more favorable for growing conditions, wetter conditions, open canopy, shade provided by local structures like shrubs, stumps, or the edge of a shrub pattern. And keeping the seedlings separated enough so that they're not, they've got time to grow rapidly before they kind of get a lock on or hold on to the site. And To our mind, you can do this with relatively low densities. In this particular prescription on the screen, we're looking at about 100 stems per acre, a density which is much more in line with where we'd like to be able to get with most of these pine and mixed conifer stands. The other thing, of course, would be to how would you use this ICO pattern at larger scales, particularly across a site? And here what we did is we condensed information from a number of studies that have looked at patterns within active fire old growth stands. And the table gives a sense of, if you're planting seedlings, how many of the particular seedlings you have to plant would be planted as individual trees, small clusters, or medium to large clusters, and that those conditions would vary depending on the topographic position, because that has proven to be a fairly strong driver of both the density in mature stands as well as the regeneration patterns that we've seen sampling these areas. So this again would be trying to make these conditions flexible to respond to the topography and the resources that are available in these different conditions. And the bottom row suggests different planting densities for these particular topographic positions between valley bottom, mid slope, and ridge top. Oops. So I somehow got one slide out of order here, but this is where I wanted to end. And before turning this over to Mark, I will just point out we've got several options for how we want to plant forests into the future. The top shows you 3 pictures of what different sites and conditions look like with gridded planting versus clumped pattern planting, such as we've been talking about in this talk. And certainly, to my mind, I think that on public lands where we have a priority to try to hold on to forest ecosystems and do not have a single mandate just to produce timber, frankly, we can and we should be doing better than we're currently doing. Thank you. I'll turn it over to Mark now.
Okay, nice. Thank you, Malcolm, for that start us out there. And let's see if I can get us started here on the first slide. Okay. Great. So yeah, good afternoon, everybody, and happy first day of spring. I'm going to follow up here with Malcolm, a tough act to follow here on the topic of reforestation for resilience. And this will be the second part. We'll be focusing on some other components of this topic. So a little bit of brief outline what I'm going to discuss. I'm going to just go into a little bit of detail about shrub considerations when we think about reforesting from an ecological standpoint. Touch briefly on some site prep and maintenance approaches or considerations when we're thinking about using fire as that site prep and maintenance tool. Also briefly touch on some best practices. And lastly, for those interested in monitoring and research of those young stands, also touch on that topic as well. So jumping into this first topic here focused on shrubs and conifer seedlings. One aspect of this I think it's really important to cover is how is our understanding of the relationship between conifer seedlings and shrubs in, say, a post-fire environment in particular. And based on a variety of publications and studies out there, particularly some of the most recent publications, what's become really clear is that this relationship can be variable depending on the ecological context in which those young seedlings find themselves. And in that, if it could change pretty dramatically or significantly with a variety of factors based on the timing of establishment of those young conifer seedlings versus the expansion of the shrubs in that system, the shrub or conifer species in question and the interaction between those individual species, as well as the overall cover of shrubs in the system. There's also site conditions, climate, aridity gradients to consider here, as well as forest type. And then as well as considering planted seedlings versus natural regeneration. They can act very differently. And I'm only going to, for the sake of brevity of time, I'm only going to cover a little bit of this topic, but just wanted to point out there's a variety of ecological contexts those developing seedlings can find themselves in. And let's take planted seedlings, for example, in these post-fire environments, particularly in a high severity patch shown as this photo below, on the Innu National Forest in an area that had been planted maybe about over a couple decades ago. In these areas where particularly a variety of studies that are coming from more arid parts of the globe, and that include areas here in California, we're seeing studies demonstrating that there could be positive or facilitative interactions or even just neutral interactions between shrubs and planted conifer seedlings. These studies range everywhere from the Sierra Nevada to the southwestern United States to the Mediterranean region of Europe. And in many of these studies, there shows some pretty definitive effects that shrubs have a neutral positive effect, particularly when we start to look at the increased temperatures associated with today's climate change patterns, and reduced snowpack associated with that climate warming. And the mechanism seems pretty clear that a lot of these shrubs provide shading that buffers these conifer seedlings, their microenvironment in these large high severity patches that could be pretty inhospitable environments for those developing seedlings. So, for example, one study clearly demonstrated cooler temperatures, higher relative humidities, and reduced vapor pressure deficits. And all of those are more conducive to the growth and survivorship of the developing conifer seedlings in a warming climate. If we take a look more at the natural post-fire generation patterns, once again, kind of summarizing several of these studies I've listed below, but there are others that aren't listed. I think one thing that's very clear among these many studies, probably clear to many of you as well, who have looked at these high severity patches, is that they don't favor, natural post-fire conifer regeneration because of that distance to seed source issue Malcolm brought up earlier, among many others, like the microclimate factor as well. But rather it's favoring shrubs, hardwoods, and grasses, species that can recover quickly through sprouting or through existing seed banks that can take advantage of those post-fire, high severity post-fire landscapes. And, we do see, in contrast to what I mentioned earlier, we do see examples where there are clear negative effects of shrub cover on post-fire conifer seedling density, for example. But what's pretty clear about many of these studies, once you start to dig into it more clearly, is that those negative effects are either non-existent or very weak until you get to very high levels of shrub cover, such as shown in that title slide Malcolm showed. There are examples of this, particularly when you get above 60% cover, but it especially becomes apparent consistently across studies when you get to be about 70, 75, 80% or greater cover in those high severity patches, which is not uncommon, right, in many of those areas. But that's particularly the threshold where we start to see that negative interaction. And shrubs can have a positive or no effect on sapling growth, as one example of a few studies out there, which looked at not the high severity landscapes, but those unburned landscapes or the low to moderate severity fires, particularly in these contemporary reference landscapes where we've seen these overlapping fires where the natural fire regime has been reestablished or reintroduced. And in those areas, we actually start to see more of those effects. And those are, maybe not surprisingly, areas where we tend to see shrub cover on the whole across the stand tends to be more moderate, low to moderate in cover overall. So we're looking at that, below 60, 65% cover on the whole. And what I've been told, or what I've looked at in some details, some of these classic plantation studies, which do provide some informative information about the interaction between conifer seedlings and shrubs. But there are a variety of limitations of these, especially if we're going to approach reforestation from this ecological lens that Malcolm and I are talking about. In that, as Malcolm's pointed out, these plantations, they're evenly spaced, the gridded system, and they're quite similar densities. They're typically those higher densities he mentioned. So in many respects, from an ecological restoration standpoint, these represent structurally homogenized systems with no modern or no natural analog in our contemporary reference landscapes or other historical information. And in addition, many of these were established, especially the older plantations from 20, 30, 40 plus years in the past, were established under much milder environmental conditions. not necessarily in these large high severity patches we're seeing today, and definitely not under the warmer climate conditions of now and in the future. Many of them focus on these herbicide effects and manual release only, and not so much on the use of wildland fire as a site prep or maintenance tool. And lastly, and I'll bring this point up again at the end, is I think our metrics, the metrics, if you're focused on seedling growth and survival, that's great. If you're really focused on production within the stand, excuse me. But from an ecological restoration standpoint, I think we really need to look at a variety of other metrics as well, such as several of these are listed below. This brings up a larger point too, that when we think about the basic assumptions and paradigm we're going with in terms of developing these young stands and reforesting across the landscape, the existing paradigm there is a bit of an issue. And that issue is that there's this basic assumption that if we grow trees fast enough, that will help develop stands early enough and produce trees that are large enough that they can withstand the next fire that's coming down the line, because we all know that there's another fire coming down the line soon. But if you look at the actual patterns on the landscape today, that is the reburn patterns, and it's shown here. Excuse me, losing my voice today. You see the patterns here. This is based on the Forest Service Regional Broader Scale Monitoring Strategy Dashboard that hopefully is going to become on the line here soon. These are showing variety national forests in Northern California. Those warmer colors indicate areas where we're seeing fires that are burning 2 or more times across those landscapes just in the past 22 years. And this is becoming a much more common phenomenon, not just here in Northern California, but throughout the mixed conifer yellow pine forests and other coniferous forests throughout the state. And what I would argue is just between the projected climate change and the degree of climate change we've seen already, on top of the frequency of those reburns that we're seeing already and are projected in the future, it's clear there's no way that those trees are going to grow fast enough to outpace reburning, climate change, bark beetle outbreaks, and other interacting stressors. So what's our path forward there? As Malcolm was insinuating earlier, I would say part of the path forward is really a paradigm shift in our thinking to restoration and reforestation. So when we're thinking about reforestation, we should use that ecological restoration fundamentals to better guide us to how we should be reforesting. In other words, shifting from the paradigm of trying to maximize our growth and outpace the effects of those stressors to increasing ecosystem resilience and adaptive capacity in those young stands from day one that we put those seedlings in the ground. And that should be really focusing on those ecological restoration principles described in the GTIS 270, 278. Sure, there's a little bit of self-promotion here since I worked on those with Malcolm and so many others. Very much a key partnership effort. But I think it was really important, those, especially in the beginning chapters where we described some of those principles that should underscore and set as the foundation for a post-fire restoration. Concepts such as promoting heterogeneity in the stand, lower stem densities, compatibility with fire and biodiversity. Many of these principles can be applied to young stands from the onset. And that also helps us provide greater alignment to NRV and desired conditions from day one. It makes it much more difficult when you're trying to restore plantations or older stands that are in a gridded system at high density at a later date, once it's been many decades later. So this brings me this point of restoring to, using NRV as one of these concepts brings up this next topic of what do we know about the natural range of variation in shrub cover, the historical reference in terms of shrub cover in yellow pine mixed conifer forest throughout forests in California, for example. And one thing that's really clear, and this is showing a graphic from Brandon Collins's work and others that was published in, 2016 or 17. And basically, what they found was on the Stanislaus National Forest and the Yosemite National Park, those two bars in the left and the right, respectively, you could see a notable decline in these fire-excluded landscapes between those different sampling periods from 1911 to 2000s. And theirs is not the only study that shows this. There's other studies that show this, particularly in those areas of long-term fire exclusion and stand densification. And the exception is what we all see in these large high-severity patches, where those are the areas where shrubs are dominated in terms of their cover, especially just a few species. But this really underscores how shrubs have declined over time in many of our fire-excluded forest landscapes. And if you dig in more into the literature, and there's a lot of literature out there looking at shrub cover based on historical stand inventories and a variety of historical reference and contemporary reference information, we see that shrub cover generally averaged about 10 to 35% in these stands, but there's really dramatically high variation in that percent cover. Let's take, for example, bear clover, the short-statured shrub in many of our ponderosa pine dry mix conifer systems. And that historically would have attained about 60 to 80% average cover in these systems, such as shown in the photos below. A stand burned 2 or 3 times on the lower left photo, and then the lower right, you can see that's a historical photo from the early 20th century, showing very high levels of bear clover. And there's a variety of studies to support this. Not to mention, when we look at contemporary reference landscapes, those areas like Malcolm mentioned, Yosemite National Park, Sequoia Kings Canyon, we're starting to see some of these also in our national forests, that there are quite variable and patchy distribution of that shrub cover in these landscapes. And sometimes it can be quite high, like I mentioned below. You previously look at the slide at the bottom. This is about 80, 90% bear clover cover in this one stand that's been burned, prescribed burned about 3, 4, 5 times in the last 40 years. Another aspect, and not to belabor this point too much, but I think underappreciated for shrubs and hardwoods in our coniferous forest ecosystems, especially the yellow pine mixed conifer zone, is the variety of ecosystem services they provide. They provide a variety of wildlife habitat and diversity services. This has been shown in even some recent studies involving California spotted owls or mesocarnivores. They also provide watershed and soil stabilization. I think that's underappreciated in those large high severity patches where conifer cover is basically been eliminated. In those areas, those shrubs help hold that soil together and really stabilize the watershed. Also, they provide a barrier to invasive species. Take the bear clover example that achieves very high cover. There are examples or anecdotal evidence that they can resist the invasion of maybe species like cheatgrass. They obviously provide biodiversity, particularly when there's more than one species that dominate in the understory, and also pollinator habitat. And I think it's also underappreciated, the cultural resources, the value. I think there's a lot of, recently we've seen some of this for black oaks and the value for local tribes in California, but there are a variety of other species like blue elderberry and others that are important shrub species from a cultural standpoint for many of our local tribes. Soil nitrogen fixation for many ceanothus species. Bear clover, there's some evidence that it can promote a low intensity, low severity fire regime that's highly frequent and beneficial for our forest ecosystems, as we know. And as I mentioned earlier, these shrubs can buffer the microclimate for conifer seedlings in the right environmental context. Lastly, it's probably obvious, but we're stating that when we have these large high severity patches and conifers aren't able to recolonize these areas, and there are many of these areas, as Malcolm mentioned, we probably just won't get to in terms of reforestation actions, it is reassuring to know that those native shrubs are going to be there, and hardwoods to be able to, through resprouting and seed banks, to be resilient to those various stressors, because they can continue to provide these ecosystem services in this warming climate and all these reburn landscapes, even though we don't have conifer cover to provide the benefits and the ecosystem services of a conifer forest. Those might be our best bet in terms of actually providing the basic services that are needed on those landscapes. So, I've described a variety of the benefits of the shrubs, but when are they really a problem, particularly in these high severity patches where we focus our reforestation? And there's really, in many of these studies, appears to be a threshold shrub cover about 60 to 70%. I mentioned it in my earlier part of the presentation about the interaction of shrubs and seedlings. You see this there in these high severity patches where ceanothus and arctostaphylos species, are like mountain whitethorn and other species. They become quite dominant in these post-fire landscape, in these post-fire environments. And they are associated with low post-fire conifer seedling densities below the natural range of variation. So we know there's those negative interactions when they are dominant and achieving very high cover. There's also some evidence in some studies to show that they foster greater reburn severity in some forest landscapes after the initial fire, after the initial wildfire. But what I'd stress in that reburn severity piece of it is, I think that if you look at the several studies that looked at this question in detail, it's usually not shrub cover that's driving the major increase in reburn severity. Rather, it's that residual dead and live, whatever is live, but particularly that dead fuel load from snags, logs, coarse-woody debris, fine fuels, and everything that's really driving the probability, the increased incidence of another high-severity fire or a mass fire event. Lastly, it's also worth stating that when you get a high shrub cover, that it's not just conifer seedlings, but it also lowers that herbaceous plant biodiversity occurs in the understory. When we start to think about site prep and stand maintenance, Malcolm touched on this a little bit. What I want to do in my part of the presentation is really focus on, I think, what is an underappreciated tool for site prep and maintenance, and that is using wildland fire. And sure, it can be challenging at times, but when we have the opportunity, it can be very effective at reducing fuels and shrub cover prior to planting where that's necessary. This can be accomplished through a prescribed burn or even a cultural burn. And even in areas from a wildfire, let's take areas that have reburned as they become more common. Areas that have reburned in 2 or more wildfires can have especially low fuels and shrub cover and might be especially suitable areas for planting with minimal site prep, depending on those post-fire conditions. Fire is not just a great site prep tool, but it could be an excellent stand maintenance tool in that increases heterogeneity and resilience. I think this is especially true for our existing gridded plantations, where, as Malcolm attested to, there's high densities and clearly homogeneous spatial structure. Fire can be a great way of starting to build in that icostructure. Young shrubs, interestingly, can potentially act as a heat sink in these young stands. So if you put a prescribed burn and you're doing it in the spring or the late fall, for example, when shrubs have a high foliar moisture content from being able to take up that soil moisture, especially in the fall, take that soil moisture up very rapidly compared to neighboring trees. That could be really effective at buffering the effects of heat in those seedlings, those developing seedlings from the shrubs under the right circumstances. Fire seems to be best applied in stands that are about 13 to 20 so years old for various reasons. And fire is a key ecological process in many of our coniferous forest ecosystems in California. And so even if it's even though the concept has been repeated many times for mature forest stands, I think it's very valid for young stands as well to reintroduce that key ecological process early within that time horizon I just discussed. And based on a handful of studies, it looks like mechanical pretreatment may not really be necessary a lot to really get fire in that system and to achieve the right survivorship post-fire that is desirable in the stand. But there are some benefits that it might actually increase burn season. When it comes to reforestation and some best practices, I think there's some things that, based on the literature available, and once again, those basic ecological principles, we can point to pretty clearly. One, maybe avoid planting in fire-prone and high-fuel areas where those areas exist, as well as high climate exposure areas like our lowest elevation forest stands, south-facing low elevation slopes, for example. And frankly, I think one of the best ways of identifying those areas is if the landscape is severely burned at a large scale, using the post-fire restoration framework could be a really great way at identifying where these areas are to really deprioritize these areas for reforestation. In addition, stands that have ample natural conifer regeneration, based on a variety of studies, it's clear areas that burn at moderate severity or small high severity patches typically aren't the areas where we have the greatest reforestation need, because a lot of natural conifer regeneration is relatively abundant in these types of burned areas of the landscape. And as I tested or mentioned to earlier, shrub control really doesn't seem that necessary when shrub cover is low, that is below that 30 to 50% threshold, unless it's anticipated that shrub cover is really going to take off and achieve those really high dominant levels in the near future when seedlings are going to be planted in the ground. Otherwise, I've heard very, very low thresholds of tolerance in the past, 5, 10, 15%. I think we can probably bump that up a bit higher based on our available scientific information. Also, lastly here, just some things maybe to think of from, once again, an ecological reforestation standpoint. Major soil disturbances like ripping, plowing, disking can have pretty significant impacts to soils and wildlife habitat, increase in invasive plant spread. So maybe a thing to generally avoid when it's in a variety of our ecological contexts. And the indiscriminate herbicide use, the use of aerial herbicides, these are really going to impact a variety of other species in the ecosystem, plant species of conservation concern, those culturally important plants I mentioned earlier, pollinators, non-target desirable shrubs and herbaceous plants. It could even, and there's evidence to this, increase the cover and spread of invasive plants in the reforested area. So I think spot treatment is probably preferable in those planting microsites where it makes sense. And then this is maybe just one last point I make that I've seen on a number of forests where there's an opportunity to manage. There's a wildfire and it's being managed for a variety of objectives, including resource objectives. It just would make a lot of sense to manage that fire so that it can actually thin out those dense plantations, create some of that eco pattern, especially when it's burning under these low severity ideal conditions. When control lines are kind of built around to protect that plantation, it really is just postponing the inevitable. And frankly, I think it's a missed opportunity to try to restore those plantations that really need some reduction in density of fuels. For those interested in monitoring and research, these are just some ideas that we've had about what would be really good things to look at. And I think you've heard this enough time that experimenting with variable planting densities, looking at cluster planting, low densities, incorporating hardwoods is an obvious component of that. But as I touched on early in my presentation, looking at more indicators besides just growth and survival. What about the seedling spatial pattern? What about the fuel loading, the stem density, the reburn potential in those young developing stands? Soils, there's like virtually no information about soil health, mycorrhizal fungi, and so other aspects of those planted stands, as well as biodiversity, plants of cultural importance, invasive species. The list really goes on. Habitat for wildlife species. I think we can really expand it to a broader array of indicators to look at it once again from an ecological restoration standpoint, rather than just growth and survivorship. So in conclusion, and I apologize, I'm sure I went way over, but I want to emphasize what Malcolm mentioned at the beginning as well as my presentation, that I think from an ecological restoration or ecological reforestation standpoint, planting at lower densities with more variable spatial arrangements using topography and microsites as a guide would be really advantageous and more in line with those ecological restoration principles to produce resilient stands in the future. And also recognizing the importance of shrubs in these forests, not as just competing vegetation. Sure, that's true, but that's not true in all circumstances, and it's probably becoming less true in the future. So the relationship with tree seedlings really changes in that context of a warmer climate. And if we're really focused on ecological restoration, we need to think about that, the NRV considerations, what the historical importance of these shrubs in the system, as well as the many ecosystem functions and services that they provide. And lastly, when it comes to maintaining or even prepping a site, consider using fire in young stands as that site prep or maintenance tool. And perhaps most importantly, it just really comes down to this in our presentation is, I think both of us have seen very little experimentation when it comes to reforestation. And so if there's one take-home message I'd like to, or both of us I think would like to communicate to all of you, it's let's try to experiment a little bit more with different planting designs and learn from them. Because when it comes to things like climate change, rapidly changing fire regimes and other stressors on the system, it would really be of great value and interest for all of us to really focus on trying to experiment, try to learn from it, and focus on this ecological or ecosystem restoration paradigm rather than the more narrow focus of growth, which is not necessarily going to get us to a more sustainable future for many of our forests. So with that, I'll stop sharing my slides. Thank everybody for listening to our presentation, and I guess if there's time for questions, we'll take them.
All right. Thank you so much, Malcolm and Mark, for your great presentations. Certainly enlightening. So yeah, we have about 9 minutes now. We'll open it up for a Q&A session. And I think both speakers have agreed that they can stay, maybe 5 minutes after if we do have a ton of questions. And yeah, so because we have such high attendance, we ask that all questions be submitted through the Q&A chat. And then if we're unable to get to any of these questions, we're going to send them off to Mark and Malcolm, and they will follow up with some responses that we'll email out to everybody who attended. So yeah, we've got already 6 questions here, so I'll just run through these and in order, and yeah, give a somewhat concise response considering that we do have limited time. So the first one here is from Andrew Johnson. And I think you all touched on this, so maybe just a nice recap. But thoughts on how you communicate irregular planting patterns to planting crews, and how do you make sure they are implemented correctly?
Well, I'll jump in first, and Mark, you can add things. But I think that sometimes we overestimate how difficult this problem is. Even with the cluster planting that we've talked about, there's still very definable objectives of how many trees you're going to put in per acre, the general distance between the clusters that you're going to plant, and the use of the microsites or looking for the advantageous microsites. I know that typically, and I've worked on planting crews before, compliance is done more on a typical, you walk, is it 12 feet since the last seedling you put in, and how many seedlings total does it come to? I don't think we're ever going to have that micromanagement style of compliance. There has to be a certain amount of faith in the planters to be able to adjust to these circumstances, but I don't think it's by any means that complicated or difficult to do.
Malcolm summarized it well. I have nothing to say to add to that.
All right, thanks. All right, so our next question is from Leslie Stoop. Can you speak to the controversy over planting giant sequoia seedlings in areas that have suffered high intensity fire? And maybe assuming you all know, first discuss what that controversy is before diving into a response.
Mark, this one's probably best for you.
Yeah, I could try to tackle this. And this one I'm going to have to give a probably abbreviated and non-satisfactory answer, because this is this question is like a whole nother presentation in itself. But I think that if I'm just going to guess the controversy of planting giant sequoia seedlings, there's been some controversy, particularly on National Park Service lands, about planting in wilderness areas, and whether that, under the Wilderness Act, that's a valid thing to do. I'm not going to get into the wilderness piece of it. I'll get to the ecological piece of it. That's only because I've been our program in partnership with the U.S. Geological Survey and the National Park Service are the ones who've been collecting these data in places like Sequoia Kings Canyon after the K&P complex. And kind of cut to the chase, what I can say is there is clear reforestation need in some of those groves based on the post-fire regeneration we've collected there, regeneration data, as well as places like the Windy Fire and the Giant Sequoia National Monument. And the part of the controversy and misunderstanding is that giant sequoia is a semi-serratinous species, and you see relatively high density of post-fire regeneration in that species compared to our other conifers, say like ponderosa pine or sugar pine or white fir. But if you look at the actual reference densities, the actual densities needed to reestablish the giant sequoia within the stand, based on the historical or even contemporary reference densities, those post-fire densities of giant sequoia that we're seeing in those high severity patches are far below, in some cases, orders of magnitude below what those reference densities are. So sure, giant sequoia will come back in some of those groves in the areas that burn at high severity, but at such low densities that, and there'll definitely be patches where they may not come back at all, especially under our warming climate, that it brings up the obvious question of whether we as management agencies should actually go in and reforest these areas to do management intervention to actually restore that important iconic species in those groves. And so there's all other aspects of it. I know we don't have a lot of time to answer the question, but that's kind of the nuts and bolts of it.
All right, thanks. Malcolm, do you have anything to add?
No, Mark's covered it very well.
All right, thanks. Well, the next one's from B'nai Dar Abrams, and this one's directed right at you, Malcolm. How might your ICO analysis change or be adapted to subregions, some coastal, that experience regular dry season winds like Santa Ana's, Sundowners, or Diablos?
Wow, can I pass this one to Mark? This is a tough one. I do think that, you know, the implied thing here, which is really important, is that you've got strong winds in those conditions. And if you've got a more open stand condition like ICO is, it's unclear to me exactly how high winds would operate in those systems. And to be perfectly honest with you, I don't know of any ICO studies or reconstructions that have been done in those type of systems. I think you'd still get the benefit of reduced surface and ladder fuels in the opening parts. But of course, one of the other things that's been suggested about the advantage of ICO is that it does reduce wind transport of radiant and convective heat. And I could not lay that claim in these systems that have really strong winds. So I'm dancing around. I'm not really giving you an answer, but I'm trying to say, I don't know what the answer is. So, no.
Yeah, I'd agree with Malcolm. And I think that's a scientific uncertainty. It's when the winds, those phone winds and others get strong enough, and they really could blast through gridded as well as an ICO pattern. But you know, those winds, it depends on the wind speed, the ecological context of like what's the vegetation surrounding those young stands and so many other factors. And so it's probably just an area where we have room to learn from, but that's probably the best answer I can give.
All right, thanks. So this next one here is from Chris Dunn. It's a little bit on the long side, but I'm going to just go ahead and read it. So Dr. Meyer suggested fire-killed trees end up being a primary contributor to high severity reburn, although also suggested mechanical treatment is not necessary to burn. What about snags as hazards to the fire practitioners reapplying fire and burn landscapes? Should we salvage fire-killed trees to help restore fire as a process following uncharacteristic fire impacts, given the difficult operating environment and potential for undesirable reburn effects? That one was directed at you, Mark.
Okay, I guess I can't avoid it. Ask Malcolm to follow up if he has something to add. At least if I'm interpreting the question of Chris's correctly, one thing I would say is in many of these young stands, it would make a lot of sense when we have, you know, there's enough accessibility and we have the tools and everything to do so, to reduce those hazards and reduce that fuel loading from the onset. I think that there's just a lot of evidence and a lot of general scientific evidence to support that from a variety of standpoints. You know, as pointed out in the question, that can not only reduce hazards to you know, fire managers, fire staff that are trying to reapply fire in that area, but also the common cited hazards of snags as a planting environment. So when planting crews are out there, you never know if those snags, when they're going to fall and that sort of thing. But, you know, reducing that fuel hazard in those stands, those hazardous fuels, as I mentioned earlier, one of the primary drivers of, let's say, a high severity reburn would be really advantageous. The tricky part is that those areas that we salvage, we're kind of limited. You know, it's think of from a Forest Service as a management agency. Oftentimes we can be limited about the total number of areas we can salvage and to the degree, and not all areas are accessible. And so the question becomes, in those areas, what do we do? And maybe I'll pass that question off to Malcolm, or at least hear his 2 cents on it. But those are the challenging areas where we have more limited management options.
Yeah, I wouldn't disagree with anything Mark said. I mean, frankly, on public lands, we put ourselves way behind the 8 ball by having to go through, you know, I'm not saying anything against it, but NEPA evaluations, which means that you usually don't get into the site to either burn or plant it for, you know, 3 to 5 years. And You can have a real problem then in terms of the snag and wood loads by that time, as well as sometimes the shrub cover. So I wish I had a better answer, but to be perfectly honest, it puts you in a huge hole when you have to wait that long.
All right, thank you. So yeah, I think we're at 3:01 now, so I think maybe I'll ask two more questions that I picked out here, and then the rest we'll send you all and follow up on those. So this one's from Gretchen Fitzgerald. When you were talking about TPA, you are talking about a mature forest. It seems to be comparing apples to oranges when comparing seedling TPA to mature TPA. Is there any research that looks at how many TPA a natural forest regenerates to achieve the mature TPA you are using as a reference?
Well, I'll make a first answer and then Mark, you can jump in. One of the problems we have is that almost all the experiments on tree planting densities and how they develop into a certain density at mature level are from silvicultural experiments that have used regular spacing. To my mind, we don't have a lot of information about that transition, but I would say that at least by inference, the fact that we're getting 60 to 80% survival in a lot of the tree plantings under current practices of putting 2-year-old seedlings in the ground indicates that, at least to my mind, there's not the reduction of the TPA that you would need to get down to get to that mature level of stand. So I do agree that it's difficult to predict how many seedlings are going to survive till a later age, particularly as you're putting fire back into these stands. But clearly, if we're putting in 3 to 4 times the number of seedlings that you would have in the mature stand, to my mind, there's some kind of a disconnect going on there, and it's too many stems and too much fuel going into the stand.
Yeah, that's a great question that Gretchen's posed. I think there's 2 or 3 things I can say about it. One, in addition to what Malcolm said, is in my experience in the Southern Sierra, for example, including there on the Sequoia, is when I look at many of these plantations that were established a number of years ago, the survivorship of these planted seedlings has been amazingly high. And so when you look at these stands well into the future, they're still retaining these very high survivorships and high densities. And it brings up my second point, is that I think, to me, the lesser of two evils is to plant at a lower density and then end up with your final density being on the low end of the range. Then planting too high, having a high survivorship has been, as pointed out, observed in many of these plantations, and then ending up with trees per acre that's well above the natural range of variation or the desired condition. And then you got a bigger problem, I think, in terms of trying to thin out that stand in one form or another. The last point is that we're often thinking, and I'm just as guilty as anyone of thinking about the desired condition of trees per acre from a natural range of variation lens. But if you start to think about it from a future lens, a future range of variation, considering climate change, most likely these densities are going to be even lower. They're going to be at the lower end of that historical range of variation, or just more variable over the landscape. So I think once again, to the lesser of two evils, it might be fine to have those stands end up with the mature trees per acre being on the lower end, simply because it's more aligned with that future condition.
All right, awesome. Well, thank you. I think actually, we're at 3:05, so I think we will wrap it up now. We have 13 unanswered questions, so y'all will have to follow up on those. We can send them out to the group, and we appreciate everybody providing these questions. So with that, I want to thank Malcolm and Mark for this very interesting presentation. Just remember that we have our next presentation through the seminar series on April 2nd, and we'll have Lenya Quinn Davidson speaking on the evolution of prescribed fire in California. So that should definitely be an exciting talk that everybody should try to attend. And then, before we sign off, please keep an eye out for the webinar evaluation that will be emailed out this week. And once again, thank you for everybody who attended, and we look forward to seeing you in future sessions. So have a great day.